Okay, so let's start today. So I will be asking you guys to calculate from the acceleration spectra that you have calculated for the last class for the 3 site, right? So you can use that to calculate the displacement spectra and take the square root of the displacement spectra for both the horizontal components, so that means north, south and east, west, and then plot the displacement spectra, and from that displacement spectra amplitude values you calculate the moment magnitude of that and also the corner frequency. You can choose it at least now manually, but it can be done also by making the inverse program to calculate M0 and FC, but that's okay. That is not the main part. The main part is this, to choose your M0 and FC, right? And if you choose M0 and FC, from there you can calculate the moment magnitude. Means if you choose the amplitude of the displacement spectrum, maximum amplitude, and that you can relate it to the moment magnitude, right? So let us see if I write the observed spectra, say observed acceleration spectra, right? Acceleration spectra at a distance for a distance r and for a frequency this. So that will be equals to 1 by r of that is the geometrical spreading factor plus the source factor, your I with your frequency, okay, multiplied by the site factor at a point at the jth recording station, okay, multiplied by the path factor. So that will be equals to r comma f, and multiplied by your I as a function of f, right? So for a IF for a acceleration spectra will be equals to 2 pi f or 2 pi f with the I, that will be square, right? So that's your values, and this is be also, it will be equals to the c, because this is a constant term, and you can write it out. This will be equals to your observed acceleration spectra. I write it acceleration spectra at a point for the source I and the site j. You can write it like this way, 2 pi rf into 2 pi f square into c divided by r into SOI f into Sij. This is for the site. So this is I for the source and j for the site, and then e to the power. So this will be equals to path factor. So path factor will be equals to e to the power minus pi f r ij into qf. It is the q factor into the beta, right? So that's the case. So if I divide it with your observed Ij f in r divided by 2 pi f or 2 pi if, okay, the square, right? So if I divide it with the 2 pi fi square, then this will be equals to c by r into SOI into f plus Sij with your f into e to the power minus pi f Rij into qf. So qf is fine. Let's see qf into beta, right? So if you multiply this with your Rij, this is all Rij. Okay, so this is the distance. Okay, so Rij. So if we multiply that, when I show that the compensation of the distance has been taken into account, divided by 2 pi fi square. So this will be equals to the displacement spectra of dfr, right? dijfr. So that will be equals to c into soi into f plus dot into Sij into f into this one, e to the power minus pi f Rij divided by qf into beta, right? So this is your displacement spectra. Now what will happen is this, that this displacement spectra you can calculate and plot. Okay, so this displacement spectra you can plot. So this will be the displacement spectra plotting. So this is your f value and this is your d displacement spectra in your, and that displacement spectra will be equals to like this. So this displacement spectra will be looks like this. Okay, so this will be making a pictures like this. So if you see this displacement spectra, then you will have a, means this is ideal, you cannot get it like this way, might be there is a pictures like this or something like that, but that's okay. So you can draw a line which is basically the low frequency part of this one, right? And read this number in a log scale, because this is your log, this is your log also, this is both are in a log scale plotting. Calculate this and also calculate this part, this frequency. Okay, so if you can do that, then this will be this number will be equals to this, and then you can have this c, the constant term c will be equals to your m0 into r theta phi into v into f divided by 4 pi into rho s into beta s cube into r0 equals to, r0 is a 1 kilometer, right? R0 equals to 1 kilometer. So R0 equals to 1 kilometer, and then rho s is the source density. So density at source. So density at source, right? You can take it as a 2.767 gram per cc. Okay. And then you can see the beta s equals to say 3.4 kilometer per second, and r theta phi equals to say 0.55. Okay, v equals to 1 by root 2, and f equals to 2. And use this number, and R0 equals to 1. So that you can take, so compute the C value, and that C, so from that C you do not know this number. So from here, so this part, this is your source part, so you can calculate from here by multiplying this thing and calculate the values of M0 from here, right? So from the maximum amplitude, calculate the M0 value from here, because all these numbers you know, all this number you know, and also you know this df, so where it will touches here, that also you know. So if you know that, you can calculate m0. So if you know the m0, then you can calculate your mw from that relation. It is 2/3 log m0 minus 16.67 or 16 point this one. So calculate that. So if you know m0, you can calculate what will be the mw values. Okay. So so before doing that, you first calculate the acceleration spectra, and from the both north-south component and east-west component, and calculate the average of these two from the acceleration spectra. Okay. So make it an average horizontal. So this is average. You can do it at the HF, average horizontal spectra, and then from that average horizontal spectra, you can do this part. Okay. And already you have calculated the distance of that station from the source by seeing the S minus P value and multiply it with 8. So that will be the distance, and the depth of the earthquake is around 49. This is around 49 miles. So 49 miles means it is how much kilometer? 49 into 1.6. So that will be the kilometer. So this is the depth of the earthquake. Okay, and the distance, epicentral distance, you can find it out. Epicentral distance, you can find it out from the, so that distance, the epicentral distance will be equals to 8 times of Ts minus Tp. Right, so calculate that. So therefore R value will be equals to the square root of epicentral distance plus the depth. So that's square root, right? Because this is the depth of the earthquake. This is the epicentral distance. So this is the D, and this is the epicentral distance. This is the recording station. This is the earthquake, right? So this is your epicentral distance, and then this will be the R value. So R will be equals to Rij. So R will be equals to this square plus this square root it. Okay. So let me see how many of you can calculate the moment magnitude. I know the moment magnitude values, so calculate this number. See whether your results satisfy that condition or not within a reasonable accuracy. How many of you have a OffSpy installed in your computer? But you have that OffSpy? You don't have that OffSpy. If you are doing the seismology and if you are good at Python, you should install the OffSpy in your system, because that's a very important software nowadays. Okay, you can.
kg per meter.
Be careful, because that might set the MGO in some different unit. So
that you need to be careful about.
yeah, I mean, otherwise it's the same thing. Okay, before you start the things, let me complete this teaching by finishing another part. I like you guys should know, because
Yesterday when I was discussing this SSR method, I told you one specific point, that the SSR you cannot calculate if the record simultaneously not available at both the rock site station as well as the soil site stations, right? So that if both the records are available, then we can calculate the SSR, or the standard spectral ratio method, right? That's the criteria for doing that. Now, if it is not available in all the sites or all the records, the corresponding rock site is not available every time, then what should we do, right? So then I can do these things. I can use this SSR by a means of a generalized inversion method, general inversion method, or inversion technique. We call it as a inversion technique. This technique is called nowadays is a GIT, general inversion technique, GIT technique. Okay, so this is for the SSR calculation. Now, again, I am writing it OIJ, observed IJ at FR is equals to the your source path. So whatever is the source path, that's fine, into the site path, and then there is a path, the path factor, right? So path will be equals to PFR, right? So this is the case. Now, if you can do it, so it is in a frequency domain, okay? In a frequency domain, so that means the spectral part, okay? Now, if I take the log of both the sides, so this is your log of OIJ with the FR, that will be equals to log of SOIF, then what? Plus log of Sij with your F, and plus log of path, right, F and R, right? So that means log, if I write this log OIJ, as I say, this number I write it as a small OIJ, okay? So that will be equals to this log of SOI, if I can write it SOI with your F, okay? SOIF plus this is your SIJF, right? And path factor P is equals to PRF is equals to e to the power minus pi f Rij into QF by beta, right? So if you take the log, then only the e to the power something, so it will be minus pi f Rij into QF with your beta, right? So that will come. Make sense? So now this is completely a linear equation, right? So this is a linear equation. So let us see, we have a lot of source So that means a particular site area, we have several sites, and these are the several sites which is, let's see, this is your rock site, and then we have a lot of stations which has generated the earthquake, right? And these things are sometimes recorded at the site, sometimes they may not have record, so that's okay, that's fine. Sometimes the rock site has not been recorded, but other site has been recorded. Sometimes rock site is only recorded. So these are all possibilities there, right? So let's see our I. I is the number of source or number of earthquakes, right? Now this number of earthquake may be, say, I can say 4, right? And let's see, J is the number of station or number of recording station. Number of recording station, let's see, this is 5 or 6, right? And so we are, some records are available. Ideally it should be 20 records available, but might be due to the some station are not recording all the time. So then we need to change it out, right? So this is your OIJF into R. Oh, so let's see. I have a 1 by R here. So that 1 by R I multiplied it here. So this log of Rij. So this everything is being taken care of. So that part is fine. So first I multiply this one and then I take the log. So that's okay. So that is your things. Now, so you can say that the O11, so that means first earthquake, let's see, this is 1. So first earthquake recorded at the first station. Let's see, this is your first station. So first earthquake recorded at first station is equals to the source at a first station, okay, this one, plus site at a first station, okay, for the frequency, and then minus of pi FR11 divided by QF into B, right? So this is O11 this. Next we have a first earthquake might be recorded at the third or fourth station, at the fourth station. So O14 will be equals to SO1 into F into SI4 into F minus pi F Rij divided by QF into beta, right? So that's fine. So similarly, you can do for all the station wherever you have record. So we have on this side A11, let's see A12, let's see O13, might be A14, might be O15. So these are the station. Then O21, O25, 22 might be O23. So these are all the records. We can write it on the left hand side, all the recorded data. And on this side, we are saying that, okay, this station, this source station, this source has been recorded. So let's see, this is your S1, or might be, we can say it as a, let's see, for the first station it has been recorded, so it is 1. The second station, there is no source, because the second station has not been recorded, but there was a, sorry, there was a, I take it back. Uh, so this is first station when I recorded, and then there is all other 0, 1, 2, 3, 4, 5. 5 stations are 0, because this is only for talking about the first station, first source, right? And then there are, oh sorry, number of sources 4. Okay, so let's see, this is the 4. So 1, 2, 3, 4. And then this is the first site. So this first site has been recorded. Then there is nothing record available, 1, 2, 3, 4, 5. This is this much. And then it is on this side. I write it as a minus of pi f of Rij divided by beta into this one, right? And then I write it on this side. Okay, this is equals to your SO1 at that position F, right? So this is SO1, but then after that there is no other record. So these are all 4 zeros, 1, 2, 3, 4, okay? And then we have recorded the site, first site, 1F, and after that there are 4 records, 0, and then this will be last one, will be the QF into B. So this is your QF minus 1, right? So you can, now this is your 1, 2. So 1, 2 means it is the first station, and then there is a second recording station, and then all other are 0, right? So then this is a 1, 3, might be 1 has been recorded, all are 0, including this one 2. So this is your third station has been recorded. Then 1, 4 means 1. So that has been recorded, right? So now you can say A011 means if you can multiply SO1, then all are 0, SIF plus all are 0, and then minus QFRB, right? So this is all, this is the same number by beta. So this way you can go on writing it. So you can create this matrix is with a only 0 and 1, depending upon which one you are writing it and how you are writing it. And here it will be SO1, S1F. So this is source, site, and path factor. And this will be a linear matrix equation with all the source here, all the site, all the observed value here, and source and site here. So this is what we call it as a matrix like D. This is your G, and this is your model parameter which you need to write. So this is your matrix thing. So this is your data matrix where you are calculating all the values. This is your G and this is your M. Now this is your few parameters you need to calculate: source, site, and the Q factor. You can calculate it out. So, but you have lot of equation because you have a lot of recording data. So this matrix is a overdetermined matrix. Overdetermined matrix. So this matrix you cannot solve by taking a inverse directly, because this is not a square matrix. Okay, so this, if it is not a square matrix, we have to multiply both the sides with a GTG and M, and so this is your GTD with this one, right? So this is your transpose of G and this one. So if you can do that, then and then you take the inverse of it. So then your GTG with your inverse, and so with your M will be equals to GTD with your inverse value like this. So your M can be calculated with your equals to so you can calculate your M by the GTG inverse into the GTD. This one, sorry, I take it back. So this is equals to GTG into M. So now if you can take these things down, then M will be equals to your GTG inverse minus GT into D, right? So that means if you can go down, or the denominator, then it is the GTG inverse into this one. So if you can do that, so this is your, so GTG inverse and into multiplied by GT into D, right? So that's D you have already provided, and from there M you can calculate. Now M means it is your all the parts, the source part and then all the site part. Okay, so that you can calculate and compute, right? Now this inversion technique does not require all the rock site station to be recorded. I mean, even if it doesn't record, we put a 0, but it will be calculated whenever we are doing it all over the inversion things. So therefore, this GIT technique, this technique is available as a free source in your worldwide domain. So this is called GIT technique. This is written in a MATLAB, and it is a very easy operation in MATLAB if you like to do. So that means this model equals to some G and then backslash of D. So that if you can do that, then you can calculate M in one line. Okay. So this technique, we do not need the earthquake to be recorded at all the rock site station. Even if some stations are absent or some rock site stations are absent, we can still calculate their values. Now please remember, these things are computed for each frequency. So that means first frequency, this is first frequency, we can write it down, then the frequency value increases and we can do this inversion loop for each frequency. And that will be, that's a big computation, but for computer it takes 3 to 4 seconds to give you all the source values. So all the source parameters, all the site parameters, and as well as you can get a Q inverse. So that means your Q value you can also calculate for the particular station. So that's the generalized inversion technique, and that way you can also calculate the site response. Okay. So this is another way of computing site response. So only thing you remember, this G matrix is only 1 and 0. So if some record is present and some site is present, then that site and that source we will be writing as a 1, all other will be 0. So if it is a first observed source recorded at the first site, if the first source recorded at the first site, we will be writing them as a 1 and 1, right? So if it is, so this many number of source, and then this many number of site, and then this is a single entry. So this is the first source, this is the first site recorded, this is the first source, might be the second site recorded, but there may be the second source that has been recorded by first station, and so on and so forth, right? All, and then the number is this. This is the second source, might be the third station has been recorded. So that will be one thing. And that way you can all create the matrix. So this matrix will be all 0 and 1. So that just indicate which one is recorded and which one, which source and which site when you are talking at, that you make it a 1. And here you put all the records, and here you have write down all the source part for that frequency or the site for that frequency, and then QF inverse. So that will help you to solve each frequency, the source part, as well as the site part, as well as the Q inverse values. And that also you can plot the Q inverse values, and if you plot the Q inverse value, it will be showing a pictures like this. So from here at 1 Hz, that value will be equals to Q value. That value will be equals to Q0, and from here you can calculate the slope. So the slope will indicate how with the frequency it does. So therefore QF equals to Q0 into f to the power n. So that you can calculate, minus QF inverse. Okay, so that you can calculate it out. So source side path all can be calculated by the generalized inversion process in a one go. Okay, only you need to put this matrix or create this matrix with a 0 and 1, depending upon which one you have a record and which you do not have a record, right? So that you can put it and take the inversion or the inverse the matrix, you can calculate the values for each frequency. So this has to be looped over all frequencies. Okay? Mathematics is clear? It's an easy thing in MATLAB. Just only you have to arrange these vectors. That's it. So now calculate the division and compute the displacement values and see how much displacement things you can get and how to calculate M0 from here. Hmm? So you can see it here. I can give you this. I think you can see from here. Can you see these things from the math? If you have any difficulty, I'll go there. Okay. You can note it down. Oops, sorry. This is. Oh. Sorry. So then just now differentiate it with the 2 pi f and then 2 pi f square, and we can see that. तो कुछ समझ में मैंने आया कि नहीं? सब समझ में है? अक्स कर लो। तो बता लो, बता दो उसको। अपना ही बेबी है तो कुछ ना कुछ बोल दो। कुछ मानो।
Sir, actually,
क्या हुआ?
we are not able to understand like that. Means that we have firstly we have to calculate the displacement
Spectrum.
and after that, sir, we have to calculate the m naught,
M0.
m0 using the formula that you have mentioned.
Right, or in the stochastic simulation that value is there.
Okay.
So you can use that.
We can use
That the stochastic simulation, that PPT, you can see that is equals to your 2 pi f square. You can go to the stochastic simulation PPT. The corner frequency you can calculate from the spectral shape. Yeah, from the spectral shape you can calculate the corner frequency, but you need to also calculate this one. This displacement at the low frequency, so that means at the zero frequency, and then from this value you can use to calculate the moment m0.
we have to use this stochastic simulation.
Yes, stochastic simulation that you have that PowerPoint file, right? I think you have. No, but the PPT file is also there, right? Or the PDF file I had uploaded it into the Blackboard, possibly. Into your Google Drive.
Google Drive.
So where is the? There is one file, should be the PPT. Is the? No, lecture 4 or 5?
Lecture 4 is lecture 5 में है sir.
Last is lecture 4.
वो lecture 4 is क्या है?
Lecture 4.
Oh, structure part? Okay. Let me upload the file. तो तुम लोग का माने उधर लेक्चर 4 तक है, राइट?
Try this one. যেটা করলাম সেটা হচ্ছে যে আপনি যে ফর্মুলাটা দিলেন সেটা আবার করছি। এইটা হলো স্ক্রিপ্টটাকে রিফর্ম করেছি। আগে আপনি বললেন যে
একটু এটাকে ব্রাইট করো, তো আমি কিছু দেখতে পাচ্ছি।
স্যার যেটা করলাম সেটা হচ্ছে ডিএসটিভিটাকে ম্যানুয়ালি পিক করবো আপনার সাথে, সো দ্যাট কোনো যাতে বায়াসনেস না থাকে। তাহলে আমি এটাকে একবার ডিলিট করে আবার করছি। এটাকে আপনার সামনে রান করছি। এটা করিয়ে দিই। স্যার এখানে ম্যানুয়াল আমি পিক করবো একটা, এখানে স্যার আরেকটা বলুন, আমি এর করেসপন্ডিং হাইয়েস্টটাতে নেব একটা।
না না, তার আগে যাও, একটু আগে। না না, মানে ওই দিকে, ওই দিকে। হ্যাঁ হ্যাঁ, এখানটা আর একটু পিছু। হ্যাঁ, এদিকে পিছু।
এরকম জায়গায় স্যার,
বলতে পারো।
মানে এটা এস ওয়েভ রিড।
রাইট রাইট।
স্যার আমি একটাতে ক্লিক করেছিলাম যেটা একদম হাইয়েস্ট।
না না, এখানে।
আচ্ছা স্যার, তাহলে যদি এটাতেই নিই, এটা নিলাম। আবার তিনটে স্টেশনেরও দেখাচ্ছি, তো আপনার বোধহয় তিনটে দেখার দরকার নেই, একটাই দেখতে
একটা দেখলেই
তাহলে আমি একটাই করছি। এটাকে ক্লোজ করলাম, জাস্ট K209টাও সেভ করছি। তার মধ্যে স্যার যেটা
কত এলো?
আর এটি দিয়েছে 53 ওর জন্য, ওই পয়েন্টে। আর হাইপো সেন্ট্রালে দিল 54। এবার এটার এটা দেখে নিচ্ছি, সেভ করেছে রেজাল্ট।
এটা K29 এ?
হ্যাঁ স্যার,
K29 এ?
K209 ওই পয়েন্টের জন্য।
টিএসটি 53 আসছে।
হ্যাঁ মানে ওই পয়েন্টে স্যার। স্যার অন্য পয়েন্টে ক্লিক করলে আবার 60ও পেয়েছি, আমি 80ও পেয়েছি।
না না, ওটা কম হবে, 53
আমার
হবে।
একটু ডাউট লাগছে যে এক্স্যাক্টলি কোন পয়েন্টে ক্লিক করলে ভালো।
হ্যাঁ, মানে ওটা তুমি আসলে করছো না বলে, মানে ওটাকে আরো ভালো করে স্প্রেড করলে, জুম আউট করলে, তাহলে তুমি
বেশি জুম আউট করতে গেলে যেটা হচ্ছে না, সেটা হচ্ছে যে মানে এই উইন্ডোর ফিটের বাইরে চলে যাচ্ছে।
মানে তোমাকে একটা পাঠ করতে হবে, মানে তুমি সবটা করলে হবে না, একটা পাঠ করলে ওটা হয়ে যেতে পারে।
আচ্ছা
তো দেখো কোনটা হচ্ছে।
স্যার, তাহলে ফর দ্য টাইম বিং আর
ঠিক আছে, ওটা 53 হলে না হলেও ওটাকে তুমি ম্যানুয়ালি ওটা মোটামুটি ওখান থেকে ওখানে K29 বললে তো
হ্যাঁ স্যার তার আরেকটা আপনি চেয়েছিলেন হচ্ছে এটা চেয়েছিলেন অ্যাক্সিলারেশন
মানে এটাকে মানে হ্যাঁ মানে এটাকে তুমি 2πf দিয়ে এটাকে ডিভাইড করো,
এটাকে
মানে 2πf স্কোয়ার মানে 4πf স্কোয়ার।
স্যার প্রথমে তো 2πf বললেন, তারপরে
2πf দিয়ে আবার 2πf, কারণ একবার মানে অ্যাক্সিলারেশন থেকে 2πf দিয়ে ডিভাইড করলে ওটা হবে ভেলোসিটি, আবার 2πf দিয়ে ডিভাইড করলে ওটা হবে ডিসপ্লেসমেন্ট।
মানে 2πf হোল স্কয়ার
Whole square.
দ্যাট উইল গিভ দ্য ডিসপ্লেসমেন্ট। ওকে, তাহলে ওই যেটা প্রথমে যেটা করেছিলাম মানে শুরুতে যেটা দেখালাম আপনাকে, ওটা
তুমি ওটাকে আগে divide করো।
ছিল,
হুম।
এটা তো পুরোটা দিয়েছিল, কিন্তু এটা আপনি বলছিলেন যে একটা একটা করে
হুম,
দিয়েছিল
হুম, হুম,
করতে।
হুম,
তো তাহলে ওটাকে
2πf হ্যাঁ 2πf দিয়ে ডিভাইড করে দাও,
ঠিক আছে
মানে করে দিয়ে প্লট করো।
ঠিক আছে। সো এই জিনিসটাকেই তাহলে আমি
2πf দিয়ে divide করো।
ডিভাইড বাই 2πf করে দিচ্ছি।
49 into 1.6, that much of kilometer. Okay, all the lectures are being posted in the Google Drive. So what's going on with yours?
So the value of moment magnitude comes out to be 7.1.
7.1?
1.
It's great because it's a 7.1. That's true.
Yes.
So how you got it? Hmm?
2 log of m naught minus 10.7.
2 to the power?
2 by 3 log m naught
Hmm.
minus 10.7.
Mm-hmm. No, but M0, you have to give. Now, what is the M0 value?
And the value is 5.011 cross 10 is 26.
26. Okay. So 10 to the power 26 to third. Hmm? So 7.1. It is coming,
Yes.
that number? Okay. Let's see. Hmm? It could be. Yeah, because the magnitude is 7.1 actually. Hmm. Huh?
I worked on that again. I got the hypocentral distance as
Hmm.
now 96.8.
What?
Hypocentral distance smaller
96.8.
for K209.
49.
I changed it.
Yeah, so you give the distance value for the epicentral distance will not be that 52 kilometers. The epicentral distance for these stations is around 25-26 kilometers. So might be you can put it manually now. We'll be seeing that afterwards. The TS minus TP calculation is not correct. Kara. तो समझ में है कुछ
I am converting into Python.
Okay.
It will take some time.
Okay. No, you need not to convert this one. But why you are doing this one?
This is a stochastic.
Yeah, the stochastic thing you should not touch. You just calculate the money or take the amplitude spectrum that you have done it last class. So just use that one. The stochastic thing you need not to touch there. So what is going on with you?
It's actually signal processing no toolbox. No? I am trying Colab.
What's the Colab?
Yes,
So Colab is working?
yes, yes, we just now started. Sir.
Sir, one more time.
When 100 times I'm ready.
No, sir. Sir, like if you tell me where to click, it will give me good result. I guess. So I can ignore K209 because it is probably not lucky for me. But K220 is good for me. K220 and 210, I have 2 more stations.
Yeah.
So I'm just.
So can you do these things by a little bit zoom?
Yes, I can zoom in, sir.
How can you?
But after zooming, the problem is that it's going to the next one.
Let's see.
So that's the problem. 210 will probably be correct. Sir, can I take one here?
Yeah. This is K210, right?
K210 is.
Yeah. No, that much distance you should not go. That is what the main problem is. So something around 4 seconds will be fine from the S arrival. From the P arrival, if you can go 4 to 5 seconds, that will be fine.
Okay, that means somewhere here.
No, 4 to 5 seconds. So that is from the P wave arrival. From the P wave arrival, so what is the are you not seeing this cursor where the X value is? Oh.
It got frozen because I clicked.
So this is 40, right?
Yes, sir, this one's 40.
So this is, yeah, you can go a little bit towards this side.
Right.
No, this side. Yeah. I think that will be fine for this.
Okay, sir.
Let's see, because it's very difficult to say because your things are not zooming out, because unless until you zoom it is very difficult to do the things. So how much it is coming?
Sir, next step is for what I will do for 210.
Okay.
For 210, R is coming, the capital R is 1616, the small r is
The smaller means the,
high percentage.
so high percentage is the capital R is fine for the K220.
Capital R is 16. High percentage, small r, this one, that is 808. Now I'll check the result here. So, 808, okay, 210. Horizontal acceleration is 50. And summary is
So what is going on or what?
Sir, we are trying.
So they had got exact number
7.1.
7.1. So how they got it? So they are the genuine and expert, because I never got it 7.1 when I have analyzed it. For me it was 7.3. So
You are calculating mobile calculation, we got terminal value and we are giving it.
okay. Looks good.
We had to calculate movement magnitude, right? That's it.
Yeah, and the corner frequency.
Corner frequency done. It's coming out different for all the three components. 3 points. So this is the graph.
No, Mane, have you computed
So this is
the horizontal spectra? Just you take the two north south and east west, make it a square and make it a one horizontal spectrum. Do not do with the both north south and east west. So make the north south square and make the east west square divided by 2. Take the square root. That will be the one single horizontal spectrum. So that you have to do. Okay, not the both the part. Both the north south east west is not required. So yesterday, you have shown me nice plot.
That was HVS, sir.
And the HB, sir, but you had also shown me last time the nice acceleration spectra of the corrected accelerogram. You have done that, right? Yeah. So this is your displacement spectra, but that is your corrected accelerogram after you do this thing. So take the Fourier transform of this one and compute that. So take the Fourier spectra of that acceleration record and divide by it with the 2 pi fi, and then that will be fine. Just 2 pi f will be fine because it's a magnitude part, so it's fine. 2 pi f will be okay. What is happening with this?
K20.
Vertical spectra.
Horizontal to vertical.
Oh.
HVR.
Oh, so you have been basically doing the smoothing?
Yes, sir.
Oh, okay.
It's smooth.
Okay. And then you plot it up to 20. Don't go beyond that.
Okay.
And also plot it in a
Log
the-
scale.
no, the linear scale will be fine, but just do it up to 20 because otherwise, and just put only your smooth part.
Sir, 2 pi fi square.
2 pi f whole square. Two-
Is equal to I omega v Fourier transform. Fourier transform is
Mhm.
double differentiation will be I omega whole square.
Square. So omega means 2 pi f. So 2 pi f whole square. So So I square is equals to minus 1. So I am not interested with minus or plus. I am interested in the mod value. So magnitude, it is fine. So just only divide by 2 pi f's. What has happened? Hmm?
That first one had a bit of a noise in it. So I was trying to do it.
Okay.
I saw that it got hit from the noise in. So it seemed like a click sound.
Okay.
Changing.
Okay. So, when you have the 22, right? That your email is 22 something?
Yes.
Okay. Mhm. So I am sending you a link. You send it to all the people so that they can download that. So in the WhatsApp group, we are sending one link. It is called Strata link. You please download this link. We will be doing it, if not tomorrow, because tomorrow Dr. Agarwal will take the class. But if day after tomorrow, we might use this link to calculate that 1D wave propagation things. Okay, so this is the program. It is called Strata, and you can download that link from the GitHub. And also those who are using the Python in their computer, they should install the OBSPy in the Python environment. It is if you have an Anaconda, then it will be very good to use the Anaconda environment to do the OBSPy. It will run nicely. And also, I think this. And those who have only the MATLAB, they can ask me. I can give you some other directions to do the things. If you like to use only the MATLAB, then I can have that. Hmm? No, any station. You can only, you only change the variable, that is the distance. The distance will be changed depending upon the TS minus TP calculation for each station. You can only change the distance. Otherwise, all the parameters are same. And what has happened?
Moment magnitude is 7.1.
7.1 एकदम. तो कैसे आ रहा है तुम लोगों को? मेरा को तो समझ में नहीं आता. तो 10 minus 10.1 or 10 to the power minus 1, and then corner frequency is 0.261. 7.126. Okay, that's perfect. That is the magnitude. You can, yeah. So that's omega square feet is this one. Okay. So, and the corner frequency coming 0.2, 0.1.2. Yeah, 0.1.2. Yeah, that's fine. Thank you. Yeah, good. देख लिया ना, जब बेबी ठीक सुनता है, अगर ठीक से बोलो तो बेबी भी सुनता है. ऐसे नहीं है जब बेबी नहीं सुनता है. अगर ठीक से बोलो तो सुन लेगा. प्यार से बोलो. हाँ, प्यार से बोलो. वो सेम मेथड अप्लाई करके देखो तो कोई दूसरे स्टेशन में. सो K220 में अप्लाई करके देखो. ये कौन सा किया है? तो K29 में अप्लाई करके देखो. द सेम रहा है कि नहीं? द मैग्नीट्यूड हैज टू कम सेम.
For running strata in MATLAB, any other model required
Means
to run the strata in
Hmm.
MATLAB, to run the code in MATLAB? So other model required or simple basic MATLAB is sufficient? Because in this, I don't have a digital signal processing.
the strata will not be, strata code is written in a MATLAB, original source, but you need not to worry about that because they are giving you the exe file
So
mostly.
it will run in
Yeah, it will run possibly. That is my idea, but I don't know. Yeah, because we are not giving anything in a MATLAB there. একবার মানে you can also see you can also calculate that the stress drop and the radius. Okay, if you have calculated this one, you can calculate the stress drop by using this relation. So this is 7 into magnitude of the moment, so m0 value, and then you can calculate r from this relation, because beta is known to you, the velocity when divided by the corner frequency, so you can find out the radius. So if you know the radius value, then you can calculate the stress drop. So the stress drop will be equals to the 7 into m0 that you have already calculated divided by 16 r cube into 10 to the power minus 6. So calculate your stress drop and the radius from these two relation, if you have m0 and fc value. So you got it or no? So you have already calculated fc value and the m0 value. So these two values are calculated. So calculate ri and the delta sigma. Just only 2 multiplication, do. Mm. Mm-hmm.
For K209 only,
Mm.
because I was like, आपने बोला तो zoom in करना तो करना। Sir, zoom in किया है sir. Now please tell me for the P wave click and S wave. Where did I go wrong?
But
Sorry, just a minute sir.
ये से आधा क्यों आ रहा है?
नहीं सर, एक्चुअली द थिंग इज कि वो फर्स्ट क्लिक में मार्क कर रहा था, जूम इन नहीं कर रहा था. नाउ आई हैव चेंज्ड इट सो इट विल जूम इन एंड देन इट विल टेक द क्लिक. सो समहाउ माय माउस गॉट शिफ्टेड, तो इस वजह से नाउ इट विल जूम इन सो दैट एग्जैक्टली आप जो पॉइंट बोलेंगे वो उसी को क्लिक करना है. तो ये रहा.
ये कौन सा स्टेशन है?
सो ये मेरा कमांड पॉइंट है.
नहीं, कौन सा स्टेशन?
तो अच्छा ठीक है सर, K209.
K209.
हाँ वो अच्छा उसने उसको प्रोसेस कर दिया.
K210 बोल रहे थे.
सर 209 दोबारा रीरन करना पड़ेगा. 210 कर देंगे. सर
तो मैं तो इधर चूज करूंगा और इधर चूज करूंगा.
सर आप यहाँ चूज करेंगे
At around 40 and then the
at around 40
and at around here.
so first click तो I'll give you.
Mm-hmm.
Okay. First click. Sir আমি ঠিক করে আসছি. ওটা একটু জুম ইনটা করতে গিয়ে একটু
ধন্যবাদ স্যার.
ঘুরে যাচ্ছে.
सुनने के लिए
Sir, C value I missed out.
हाँ
C value I missed out.
वही तो C value you have to use right
Yeah,
so
the
then only you can calculate the M0
Yes, yes. So this I found out something it is coming.
hmm?
This I found out.
Mm-hmm.
And
So then use this one
okay,
and that will be equals to these numbers.
okay, okay.
So
that
then
will
then
be C
then
basically.
from there you can calculate
So
M0.
that this will be C basically.
Hmm? This will be the C values.
Okay, okay.
So basically from then you can calculate M0 from there. Hmm.
Lecture same heading is PSHA calculation.
There's sometimes all the headings are wrong. So yeah, you just go and back to this one. Yeah. I think the name given is correct. But this inside that headings are sometimes misleading. So don't worry about it. Yeah, if you see the PPT files in your the folder, the Google folder, the name of the PPT files indicating the proper things, right? But the second slide, which is the name value or the slide things, that might be a misleading thing. So don't. I need to delete that one, but somewhere or other it has not been deleted. So go by the name as the things have been posted. Hmm?
FC was as per, I think, blue model you were
Blue model.
BRUNE.
Oh, Brune model. Yeah.
That was the blue.
Mhm. So how much is your the radius came?
So radius is coming up
687 is kilometers. Oh, 687 meters.
6.05.
Okay, and your yeah?
Stress drop,
Hmm.
it's coming out 0.
0? No. Stress just cannot come to 0. How can it be stress dot come 0? Because that number, all the numbers are there. Means 7. So your moment value is given in what?
Movement magnitude.
No, not moment value, just moment, seismic moment. M0 is what? M0 is 10 to the power 23, right? Or 26. 26. Mhm. Or in your case, it will be the 26 minus 7, so that means 19, something around 19, 10 to the power 19.
It's coming out like this.
Hmm? How much is the moment coming? M0 value?
1.49 E plus 18.
Yeah, 18, right?
1.49 E plus 18.
Into 18. So 18 minus 6. So that means it will be 18 minus 6 is 12, right? And then this is your 16 into this one. So therefore it cannot go to that level. It cannot be 0. Okay, so calculate that value. So this is not, that cannot be 0. And the beta value, when you have used, it is how much? Beta B, for the radius calculation, you have used the beta, so that beta value is equals to how much? How much you have used as a beta? Huh? No. This radius calculation is 2.34 multiplied by beta. So that beta value is how much? You understood what I'm saying? So beta value you have used how much? No, what you have used? That is what I am asking.
I don't know, I just gave the command and gave me the answer.
Huh?
I just gave the command and gave me the answer. I don't know.
No, but you have to
Because
put.
it has used some other formula.
It has used some other formula. What formula they have used? It cannot have other formula. So K into Vs. So K is a constant. So K equals to 0.37. And then Vs equals to what? Vs in kilometer per second. So how much is, you have given the Vs value? What is your Vs value?
So I don't know.
You have gone down, so when you have calculated, right? So otherwise, well, yeah, so you have given the Vs equals to 3.5.
3.5.
Right. So 3.5 kilometer per second, right? And that is what it is coming out as a 2 pi fi. Corner frequency is how much? Your corner frequency? How much is the corner frequency?
Corner frequency was coming out to be
0.2?
it was coming out different for all the three components. 0.35 for the 0.34 and 0.45.
Okay, so they said the beta equals to in meter per second, right? And 2.34 into beta multiplied by 2 pi fci. So let's do the calculation by this one. So 2.34 multiplied by 3500 if you're divided by 2 divided by 3.14 divided by point
3500, this whole divided by 2.
whole divided by 2 divided by
Divided by 2, 4095.
and then divided by pi 3.14 and then divided by 0.02 0.2 right or 0.3 I mean you got on it
8.3.
no you got the corner frequency is 0.3 or something around 0.35 yeah, so divided by 0.3
0.35.
yeah so it is how much
3726.
3726 so 3726 meters right okay 3726 meters is it the same number you are getting
So this is stress drop.
no this is RI
So I'm getting 687 something.
yeah so that is what I was
687.
134 beta SI and what is your formula they are writing you have shown me some formula they are writing is K into Vs divided by 2 pi Fs and K is the constant velocity 0.37 where from 0.37 they got I don't know so even if you use the 0.37 into 3.5 let's do that yeah, so 0.37 because they are using the 0.37 value so 0.37
0.37.
multiplied by when you are using 3.5 right so you are using the VS in kilometer per second okay so 3.5
3.5.
divided by 2 whole divided by 2 then divided by pi divided by your 0.02 anyway 0.35 0.35 you have used okay so
0.58.
589 this will be equals to in meter or kilometers R value is coming as a so it is kilometer per second so it is in kilometers so 589 meters 589 meters okay but your number is not coming because
My number is coming 687.
687 so that means you have given little bit less value of the 0.35 money point you had given might be a little bit okay so that's fine but 0.37 value I never seen but I don't know might be full
It's ready
fully
evaluation.
okay
So the thing is, I've got for K209, I'll do K210 in front of you.
Mhm.
So I have now this window,
Mhm.
Q key window is now going to allow me with the power to zoom in
Mhm.
and choose anything that you say.
Mhm.
So this is for K210. For K209, these are my results. Stress drop 0.825I, corner frequency 0.2 Hertz. This is for K209 and you are interested in M0 and MW. So MW is 5.7. And oh, my peak timing. The TP I picked was 36 and TS was 37.56. Now, if you want to change it, we can change it.
No, I am not changing it, but it is your judgment because you are the analyst, right? But what I can tell you that this number is wrong.
MW.
This number is little bit low because it has to be 7.0.
Sir, please comment on this one, sir. K210.
Mhm.
Sir, please help me to pick one.
So pick one. So then I will be picking.
I've zoomed
So then I will be picking it at this point p value, and might be. Yeah. So at this point the p value, and at this point, around at this point the s value.
Almost 38.99.
Yeah. In that case, in that part.
Here and
Mm. To क्या मिल रहा है? You're not getting it.
Sir, but the value is very high, sir. That's it.
That's the value.
7.1, sir. It's 7.5, sir.
But 7.5, 7.1 is okay. It's not bad. It's not, because there.
Our value is 7.5, but you have told us that.
Yeah, that 7.1 is the actual magnitude. That's okay. 7.5 is not bad. But if it is a 5.2, then I will say no, it's wrong. Yeah. So the 7.1, 7.5 in the data, it's acceptable. So now by the end of this saga of all the things, we have learned at least how to calculate the P or the arrival of P wave, arrival of S wave, then calculate the Ts minus Tp, then also you can see the spectra of the amplitude of the acceleration, and then how to get from the acceleration to the displacement, how to calculate the moment magnitude, how to calculate the seismic moment, and also the corner frequency and the stage drop values all from the record, right? So that is what the informations are, and if we have some more time, then we can do it next time, that we will be calculating basically the magnitude by seeing the time domain, the values. Okay, but from the spectral data, you can calculate the magnitude and you can calculate the all other parts. So another thing is left is basically the locating the earthquake, right? So that means if you have a 3/4 station, can I locate the earthquake? So that's I can show you the demonstration because this is a very simple things and some sort of a baby type of work. So this is not a very big mathematical, just to calculate the Ts minus Tp and take the distance, and then by hand calculation, then you can draw the circle and get the intersection point of all the circle should be the station location, the earthquake location. But there are big program which can run or means the routinely run in any data processing the response of the soil if I have the record available at the rock site. Okay, so that will be an useful calculation for any analysis of the recorded data. Okay, so that's our next target, and then I will be showing you if you bring your observed so that's a OBSPI software help. Okay, so that is required. So I will show one or two data sets, and then you can develop of your own. If there is an issue, ask this lady or ask the ChatGPT. So because it's a very comfortable to do the thing. So it's not a because I am not joking with the use of the ChatGPT, because I also use the ChatGPT in the same way as she was doing. So so that's okay. Unnecessarily wasting the time in coding does not make any sense to me. But the result is important, and your understanding of the result, that is important. Okay, the how you do it, that's a different issue, but need to be done in a correct manner.